Let's go live. So, hello and welcome. Alright, so we're back. Had a bit of an issue. Not an issue, but basically I was really struggling to solve this problem, and I'm still kind of struggling. I know the solution, but the problem is in Clojure it's extremely slow, and I don't know why. So I'm going to try to recode it up in Python, see how quickly I can do it, just to give myself a small boost. I guess a small ego boost, we'll call it. Yeah, let's see, PyPy. Let's just do Python. Just good old Python. Python 2. Do Python 3, that's fine. So, as previously described, the solution is, why does that give me an error? Compilation error. Couldn't find an indented block. Flakes? What is this? What is this? Oh, that's why. Yeah. Anyway, so so I decided I'll do this in Python. Now, the solution goes like this. You use a stack, and you say, okay, first we're going to find a character that has something to the right of it that is also a character that also is sort of further down the line, so to speak. We're going to find the index of that character. That's what we want to know. The indices of these two different characters. Yes, so we want to find the rightmost character that has something to the right of it that is, I think we want larger. Yes, larger. Rightmost character that has something to the right of it that's larger. We can use a stack to do this. So we're going to define one function. We'll call it find get character. We'll say kind of want to name this thing. Just like target character, we'll call it. And then we'll say we could take W, the string. That's fine. We can make these sub functions. Call them inner functions. So we've got this target character. The idea is we're gonna use a stack. So we'll just say stack equals this guy, and we're going to push at each iteration the value of the character and its position onto the stack. So we're going to do a while loop. We're going to say while true. We'll say while stack, while not stack. While stack doesn't have anything in it, while it's not empty. Or actually, no, it's going to be a for loop, just for x in range of, I think it's the length of w. And we're going to say val equals w of x, the order of that val, right? The order of that. And we're going to say if there's something in the stack and this val is greater than, now if the value that we're looking at, if the value that we're looking at is larger, then do we pop the stack? And there's also another ret index here. we can do ret1, ret2, I think is good. No, actually we just want ret. That's fine. That's all we want. So we would say if there's something in the stack and the value of this new character that we're considering, if that is larger than the top of the stack, which we're also going to get the second value in the top of the first value in the top of the stack, then we're going to say new val or check val, let's say call it, is going to be equal to this thing. It's actually going to be it'll be the second piece, and we're going to say stack.pop, and we say if check val is further to the right of ret, then we say ret equals check value. Alright, it's kind of a mouthful, and then we're going to return ret. Yeah, it's a bit of a mouthful, but it's a target character index. And in each step, so if stack, and at each step we're going to stack.push. It's going to be a tuple with, there's x is the second portion, and the first portion is w of x. So the character and the order of this character. Yeah, that's what we want. Okay, that gives us our target index. And then what we're going to want to do is, once we have our target index, so we're going to target character index. This is the furthest to the right of w. This will be the or just word or string. Call it S, I think. So this is, once we've got this, which index, what we're going to do is say, okay, this is the character that's furthest to the right that has something that's to the right of it that's larger. Right? Now we're going to say find minimum, which is min val or min character index. That's going to be a list comprehension where we're looking at all of the characters to the right, which I guess we'll take a substring of w. So we'll say all the characters that are to the right of target character index, right? Not including target character index. Take that string, and then we're going to map. Now this is tricky. Of all those characters, there is a minimum character. So really we just want min of, and we're going to map ord. Map ord on this thing, right? And then that's going to give us not the index, but the min character. See, what's interesting about that is, yeah, that's fine. I think that's okay. So let's say we'll take it'll be the left piece. That's exactly how I did it before, but the left piece is going to be this part up to the target character index and not including it. And and the right piece is going to be this piece moving onwards, right? And what we're going to want to do is set, get this min character, left min character, or just right min character, which will be the right side. Alright, so get this right side. We map everything to or, take the minimum, or we could just take the, I think we just take the minimum, I don't think we need to map anything. Just get the min character on the right side. And then what we're going to want to do is, we need to get the index, one of the indices on the right side. So we can say right min character index would be, take the right side, and just add initial. I was struggling with this before, just like, it's going to be target character index plus the minimum of a list comprehension of indices. Doesn't really matter which index you take, which is any of these indices, of where it's going to be. Oh, dude. This is so awkward. I had the same problem before. Like I couldn't formulate how to do this like easily. It was like I had to break it up into a whole bunch of steps. But basically, now that we've got the index of, now that we've got the rightmost character, the index, the rightmost character that has something larger than it to the right of it, we want to find the character to the right of it, the index of the character to the right of it that is the smallest. So it doesn't matter which one we pick though. It could just be so we get the rightmost min character, right? And then we just take any character that's to the right, so any character that's in the right side that matches, right? So we just, I guess we just loop through. We can do a list comprehension. Maybe we want just like get right index. We don't need, definitely don't need a function for this. We can just execute this. So what this is going to look like is just take the first character that matches. We'll just use a for loop, forget it. Why am I thinking so hard about this? I in range of length of right side, let's say if, let's say C equals right of I, if C equals word, or just, yeah, you know, yeah. C equals, I think this works as min. If C equals right min character, then we'll break and we'll set, just say right min character index equals initially 0, and we just set this thing equal to I. Yeah, as confusing as that is. Why is this having issues? Oh, okay. And then now we're going to say left of target character index. So now we could say T1, T2 equals W of target character index. And T2 is W of right min character index. And now we're going to say left of target character index equals T2, and then right of min character index equals T1, and then we're going to say return left plus sorted right. And this is going to be, I think, what we want. Oh, this should be which. Alright, so this took me a long time to code anyway in Python, just because it's like the algorithm itself is kind of funky. This should be which as well. How do we do? How did we do? Runtime error. Nice. On the values to unpack, expected to, got 0. Oh. Ret is probably -1. And we say if ret equals -1, or which equals -1, return no answer, otherwise continue. Forgot about that. How did we do? How did we do? Runtime error. List has no attribute push. Oh, it's append. Try that. String does not support item assignment. No, you're kidding. You're kidding. Really? I thought it did. Really? I didn't know that. Serious? You're not kidding, huh? Wow. What? Use a character. Maybe we can use a character array. I mean, okay, I guess. What do they call that? Okay. Split, right? Well, these become arrays if you split character arrays. And then now we want to join and join. Hopefully we can do that. Come on, man. List assignment index out of range. What? What? Oh, this has got to contain which. Yeah, that's my mistake. What? What do you mean list assignments out of index out of range? What are you talking about? What are you talking about? Are you kidding me? Oh my goodness. Oh man. Doesn't even print it. Oh yeah, there we go. That's print. Debug A and HEF. So print A and which +1 I guess is 0, so which is probably 0. And then we, what do you mean it's out of range? This is bullspit. What? List assignment, index out of range? Are you kidding me? Is this a joke? Is this a joke? Is this a joke? A and A0. I think I know what the problem is, though. I think I see what it is. No, wait, no, this is fine. Although this should be the right from the right side, and this should be the left side. Although it shouldn't matter. How does that happen? List index out of range. What are you talking about? What are you talking about? When you print left, we get A. What? 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 Hold on. That can't be right, man. There is no way. This doesn't make any sense. This doesn't make any sense. I think the reason is because it's a split that we're trying to take. Index out of range. Yeah, things are. I don't. Oh, it doesn't make any sense. 0, 1, 2. Okay, so you get BA, no answer. HEFG is the one that gets stuck on. HEF, 0, 1, 2. Are you kidding me? Is this a joke? Is this a joke? Maybe this is the problem. I don't know what's happening here. I'm lost. I'm confused. I think I don't know which it's failing on. 0, 2. HEF is the one it fails on, but this is like HEFG. HEF, HEFG. That's the failure point. HEF and HEFG. Which is 2 and left which? So 2. So 0, 1, 2, 3. So we split 0, 1, 2. It gives us HEF on the left. And then 0, 1, 2 should give us F. But it just breaks. Are you freaking kidding me? Is this a joke? Is this a joke? Ah! What in the heck is going on here? I don't understand. That doesn't make any sense. Come on, man. Really? You gotta be kidding me, man. I'm gonna lose my mind. I don't know, maybe I'm just tired, worn out. It's been a long day at work. It wasn't that long, but it was just this line apparently is the one that's causing issues. Like, you've got to be kidding me. Am I just going crazy here? Am I just going nuts? Am I just going nuts? What the heck is going on, man? Which left, which? It's... This is HEF. Oh, that's why I am going nuts. Because I know what the problem is. I know exactly what the problem is. I know what the problem is. That's why I'm going nuts. I'm going nuts. I know what the issue is. Empty separator. This splits on white space. There is no white space here. But it's supposed to split on every character. Like, let's see what I mean. Trim. Really? I thought there was a... There's a trim function. Strip, that's the one. I think that's the problem we're having here. No, I thought Python does. We have to use a list comprehension. Just list, is that it? Oh my goodness. List comprehension. I'm just going crazy, man. That's it. That's all it is. I'm just going nuts. It's not split. I just am going crazy. I don't realize it. Would you know if you're going nuts? Would you know it if you're going nuts? That doesn't do what you think it does. That does not do what you think it does. Let me get rid of these other pieces. Now the question is, why is this wrong? Input DKHC. From left to right, we get it was A B C D is 4. A B C D E F G H I J K. So it's 4 11 A B C D E F G H I 8 4 11 8 3, right? 4 11 8 3, and we want 4 and 11. No. 4 11 8 3. 4 11 8 3. And we end up with D and H. I think we swap. Somehow we got C in there. Oh, I remember what the problem. I did this last time. Same exact thing. It's not just the minimum here. It's the min. Use a list comprehension. I got stuck on this too when I was doing this in Clojure. X if if ord of x is greater than ord of w, which did like exactly the same thing. X if it's 4x in, right? X 4x in right. If I don't remember if the if goes to the left or the right or where it goes. I don't recall. There we go. Where's our output here? I don't know. Let's just see that. Click that button. See what happens. Okay. That took forever. That took so much freaking time. Oh my goodness. It's depressing. That took a depressing amount of time. Gotta be kidding me. What the heck? Alright. At least I'm not crazy, right? At least I'm not nuts. Like, that is an approach that we can take. That does work in Python. Now the question is, if I take this Python code and execute this with timestamps, I don't want to do that. But if I take the same code in Python, convert it to Clojure, right? Let's try that now. Let's try that now. Yes. This, oh boy. Okay. We could definitely clean up this code. First things first, let's get this target character index function. Let's build that correctly. So target character index. And this let, we'll just put, we can do this. We don't need to, we can put this on the same line. It's fine. And what do we want to call this? Target character index. No, yeah, target character index. This is going to be a function. We don't even need to, we can just do this function. And we got bindings for this function, which we'll get to shortly. So this is the get swap character, this W. There's a let in here. So these are also functions that we're going to call internally in this guy. So these can also just be functions. Like, they don't need to be special. These can just be functions that we put up here. Maybe we do want to do this then. All right, that's fine. We can leave this where it is. So some recur pop stack function here, and we can move this back a bit. Okay, that's fine. Yeah, we could leave this where it is. It's not a big deal. Okay, so what else we got here? Just stick our fingers in our eyes again, because, you know, don't do that enough. Okay, we could make this literally recursive and not even, you don't really need these things, I guess. Oh, maybe we do, I don't know. We'll leave this where it is, but this is fine. We can. Kind of want to make things a little more terse as well. Oops. Okay. I like that better. So what do we have? We have this recur pop stack, which is supposed to be recursive. We have this loop where we set the stack initially, we set the return index initially. Yeah, we do want those. And we say if the stack is empty or the top of the stack, we peek it. The first is larger than this current character as an integer, which we can just set this as an integer. No need to call this over and over again. Just the current character. Save some function calls here. Now, if that's the case, then we've got this stack red index that we want to return. Oh, that's interesting. What did we do? We said we just looped over this range. Yeah. Now this is fine. We just loop over this range for starters. So let's do that. We don't really have one of those, do we? Technically could use a reduction, I guess. Not really, I don't know. I really don't know. Okay, how do we do this? If we're just a basic for loop. Alright, let's try that. Loop with a count. So we have initial stack. This doesn't make any sense. Why are we doing it this way? Let's not do this. Let's do just S, which is S is just some string, right? And we'll just do, you know what we're gonna do, actually we're gonna just rewrite the whole thing, this function, this target character index. We're gonna just write it right here. Forget it. Now the problem that I'm having here is I'm gonna code all this up, but it's not gonna be idiomatic Clojure at all. I just want to make sure I can actually execute this function, you know? That's the problem currently. Alright. So this loop is going to be just looping over this count, I think, and then we'll update variables as we go, I suppose. So we'll just get like, you know, I don't know, count C, and we'll call this count of S, right? That's the number of times we're going to loop, and then to exit the loop, we'll say at the bottom, we'll have this recur. So if C is greater than or equal to 0, right? So if there's, yeah, if C is greater than 0, then we will recur with C decremented. Otherwise, we won't recur. Right? We'll exit our loop here, and then we can do all this other stuff in here, which is like get this value to bind this value to ord s of x. Which is actually probably want to do it the other way around. Can start off I at 0, and then we'll say what do I call that? Val is the order of, so really integer of s of x. Yeah. It's like nth. Right. Let me just say X is count of S. The increment X. Okay, fine. Got the loop. Now we say if stack and val greater than what's at the top of the stack. So if, and I guess we have to declare a stack now as well. That's at the top, ret and stack up here. Okay, got it. Right. Let's have a nice let in here. And we'll go ahead and throw that in here. Okay. And now we've got ret and stack, and ret is going to be -1, and stack is going to be list. Literally just going to be exactly what we wrote in Python. Because we need to solve the problem. It's going to be imperative, but we can actually solve the thing. So we say, okay. So now we can rewrite. We're going to rewrite the whole thing here. This is all this is going. Now it's going to be. So I'm going to write my Clojure code in the future. I'm going to write in Python first, and then just write the Clojure equivalent. Nice. So this ret stack initial values, and yeah, we say if stack, right? This val we bind here. So we say if stack is not empty. So if stack, we'll do an it's an and, right? Yeah, it's an and. If stack, I think we can do that. Question is, does Clojure have a stack function built in already? Doesn't. List, like a stack. Oh, that's kind of cool. We should use this. Conj puts an item at the front. Peak pop. Cool. So we want to use a list, and we want to say, is there a way to create lists? How do we do this? List and items. Cool, let's use a list. Let's try that instead of what I would normally use, which is an array, whatever it was. Let's use a list. Stack, and let's just do list. I like that. So, end stack, and if stack's got something in it, and if we peek the stack and get the, I think it was the first of it, of the stack, and the value of that, which this is going to be an integer, if this is greater than how did I do it? I said no. If this new value, which we bind here, yes, bind this at the top. val. If this value is larger than what's on the stack, then we're going to pop that stack. And we're going to do some stuff. Yes. Yeah. Okay, sure. I've got my camera going here. That's okay. All right. Okay, that's fine. That's okay. Okay. Let me. I'll just turn the camera away for a minute. There we go. So we've got this. Right. So trying to implement the same logic. So the idea is, it might be better to try to implement it without constantly looking at the code again. So if the stack is there, exists, and the value that we're looking at is larger than what's on the top of the stack, then we want to process that value from the stack. We want to actually pop the stack, pop that off, and process it. If it's not larger, then we don't do anything. In either case, we are going to push onto the stack a new value. So let's see, we want to rebind this. Now that's kind of interesting. We want to rebind this stack to, okay, interesting. Huh. Okay, we want to, okay, interesting. So, problem we run into is, we have this ret and this stack. These are immutable, so we have to actually rebind ret and stack later, which is kind of awkward. I think we're actually better off putting these here then. See, this is where things get a little different from your traditional imperative language. So, okay, so we have this ret stack list, and we say if, so these are going to be executed regardless of what we do. But the difference here is how we recur, I guess. Interesting. Actually, I don't know what the analog would be. Shucks. Well, no matter what we do, we're going to take the stack and push onto it when we return it. So we'll take the stack and we'll push pop append. Let me see, is there like a push pop append? What do we have for Clojure lists? Alright, we come back here. Okay. As if I'm lifting something very heavy. Alright. Is it a list manipulation though? We did have something with data structures. lists. So peak pop conj, that's what we want. Conj, okay. So what we want to do is conj this stack with a new value, which is actually going to be a vector of 2 items, which is int of nth s of inc s x, right? This value and increment x. Yes. Retyping increment x repeatedly is kind of awkward, but that's what we want to do. So this is, no matter what, we're definitely going to have this part. Yeah, we're going to increment the list this way each time when we recur. But the problem is we want to rebind stack to that's kind of awkward. We want to rebind stack to something that we popped in the case that we need to pop it. That's the part that's kind of awkward. You know what's interesting about that also? I don't know if I did this correctly over here. I think this is supposed to be a while. Now this is an interesting thing. I think this is incorrect. I think this is supposed to be a while. If there's something on the stack and this value is greater than what's on the stack, then we're going to have this check value. We're going to pop what we're looking at. Now this is very interesting. Maybe this is the optimization that I was missing. Because what we realize here is very interesting. We don't care past popping this once from the stack. In fact, we don't need to even use a stack then. Oh, wow. Oh, you know, you look at a problem long enough, you start to see some optimizations, see some differences. So the thing is, I did this by accident. I've said this in the past. It's like most of mathematics and most of like, I don't know how you express that, like most of just learning and discovery is literally a discovery. So like, I did this by accident. I was supposed to have a while loop in here, and this probably is just as fast. No, it's not supposed to be a while loop. Is it a while loop? Does this still work if it's a while loop? Is this just as fast if it's a while loop? Yeah, that's fine. Okay. Alright, never mind. Doesn't even matter. But what's interesting is a small optimization here because it doesn't matter if this is a while loop or not. And the reason is the result we're looking for is this check value. It won't change. If it's a while loop, then we're going to pop all the things that are smaller all the way down, and we're going to update with the next largest integer, and then we're going to push this thing onto the stack. But the thing is, if the next value is, it doesn't actually matter that if we pop all these smaller things out, and the reason is the furthest value to the right is already maximized by the first pop, and so any of these other pops is not going to change that furthest maximized value. And anything that could change it would have to come to the right of the thing that we've just appended and have to be larger than the thing that we just appended. So that actually just becomes the absolute, it becomes like the rule then. So now I'm thinking about it, we don't even need to have a stack, really. We just need the previous maximum. No, we just need the previous value that has previous value and it's indexed. Yeah, I guess it's an inductive step. Well, the step would be if we have the previous value, that the index of that value that has something to the right of it that is larger. We know that value, we know the index. Then the next value we look at, if it's smaller, then I guess we just need to see the last value we looked at then. We don't even care. I'm so confused now. I don't get it. What does this mean, this thing? If we just use an if? If there's this stack and the value is greater than what's on top of the stack, the index, or yeah, what's greater on top than what's on top of the stack, then we might want to update our index. Let me think about this for a minute here. There's like a bunch of different cases to consider, like what if we don't update our index? What if it's not larger? Which values we need to pay attention to? Clearly, this is just whatever's on, like we always push this onto the stack, no matter what we do. So in every case, this top piece we're looking at, which clearly we only need to look at once, is just the last thing we looked at. So we only ever have to look at the last thing we looked at and potentially update our index. When do we do that? We look at the last thing that we added and we say, is the index, is that larger than we're looking at currently? Or the last thing, yeah, is the next value larger than the previous value? If it is, then we can update our index. If it's not, then we just keep moving. Is that it? It's really that simple. Like, what if it's larger than... Oh, yeah. Oh, wait a minute. Oh, that's why. It's actually a really simple explanation. I was going to say, but what if there's something to the left that it's larger than, but it's not larger than the previous value? Well, the previous value would have to be larger than that thing as well, so you already have that index considered. So that's actually not a case to consider. So it's only, yeah, so oh wow, that's really cool. That's kind of wild, man. It's like strong induction. It's that if you already have the largest possible index, then you only need to check against the last value you're looking at. Don't actually need to check this against any of the other values, because if any of those other values, if this is less than the previous value, but still larger than any of the previous values, so it's in between these two, that implies the value that the previous value is larger, and therefore you've already checked the index. You've already considered that index, so you don't need to check that index again. Not only have you already checked it, but yeah, you already checked that index, and so you don't need to check any of those. So you only have to check the previous value. Wow, that's wild. So what does that mean? That means that you can do this a lot more efficiently. Basically, it says forget the stack. we just look at the last value. Don't need to stack at all. We would say, so check value is equal to literally just the previous value. You could say so you can do this, range minus 1 and check value equals like so, right? And we'll say if this is check value, then if value is greater than check value, and check value is always going to be greater than ret, or really it's not check value anymore, it's x, I think. Just say ret equals x. Wow, that's a lot simpler. That's a lot more efficient, a lot simpler. Holy smokes. Is this correct now? Yeah, still correct. You gotta be kidding me. Wow. No way. Oh my goodness, man. Talk about an optimization. Talk about an optimization. I feel really silly. Well, this is gonna be way faster now in Clojure. This is gonna be like ridiculously fast. Jeez Louise. Wow. That's pretty wild. That's kind of cool. Yeah, induction is fun. Induction's cool. Alright. Never mind then. Forget all this other stuff. We'll just do, let's see if we can do this with the list comprehension though. That way I can use like a reduction in Clojure. Try to program this. What this would be is you're comparing each next value, each pair of values from left to right, and you're saying every time from left to right, every time we see it's actually the largest such index, so it's going to be if check value is greater than check value. If the next, if you look at every two numbers, the second number is larger than the first number, then you want to get the index of the first number, and then you want to get the largest of all those indices. So you could write this as list comprehension. It would be, I guess it'd be for, we'll call it I in range of length of S minus I minus 1. And we're going to say I if ord of S of I is less than ord of S of I plus 1. Right? And then you get one of these guys. And then you return the minimum of that. There we go. That's what we want. How about that one? Dude, it's so satisfying to write in Python. Min arg is an empty sequence. Oh. And you can do like union -1. You can do an or. I think that works. Wrong. Um, are you sure? Are you sure? Wait a minute, something's not right. Are you telling me that this doesn't give you the same answer? Red, see, oh, it's not the minimum, it's the maximum, that's why. Duh. Duh. Hey. Yeah, talk about satisfying. Holy smokes. Dude, Python's great. But now, well, here's the issue now. You found this maximum value index, whatever it is, and like we can't do all of this in one line. Like with that was it. We were able to do that in one line. How about this stuff? Really? I never knew what you needed. I just know I'm wrong. I know it's hard for you to believe it. Gonna die on your own. I never knew what you needed. I just know I'm wrong. Well, the left side we can just call, we could just say left of, or just, could just be W to which plus right min character, right? That could be done easily, but now we got to put, we got to find the spot where the right min character is in the right side and remove it, which is kind of tricky. I kind of want to say something like watch this, you ready? Okay, I got it. So do right, goes to right dot split on this right min character, right? Then you say then I guess right piece. No, I guess you could, yeah, if you're doing it this way, actually, you can just find. I don't know why I didn't do it this way. Oh yeah, this has a thing. You can do right dot find, and then you can say right is going to be right or W of which plus 1 to right dot find whatever dot dot dot, and then, or even just W dot find beginning at this character, whatever this is called, or yeah, beginning at which, and then oh yeah, I made a mistake though. Yeah, no, it's fine. Right min character. Yeah, you find this right min character to the right of W, right? Find that right min character. Assume you already created the right side here. I guess you just do W. So you find in the right side, and then this could just be right then. Right. Plus, what is this? This left which character, or W which character, what do you want to call it? It really should be the last left character, and then plus the rest of this right.find. Yeah, I don't know if you get one-liner this, but you get pretty close. Be like +1 here. You know, you're not going to include it here, and then you don't include it here either. And that's what it looked like. Yeah, one line. Or almost one line. It's not optimized, but just much more terse. So we can do, instead of a list, we can do this, which is okay, I think, in my opinion. And a word of W of which. Yeah, that's okay. That's fine. Get the right character, and then we'll say right min index character index. Or just rfind. Find right min character, and then we can say just be a return of, it'll be W which, I don't think we need the left at all, this left thing, unnecessary, plus right min character plus right of right index plus left, oh, that's just W which plus right of right index plus 1. There you go. There you go. And all of this is hogwash after that. Alright, let's try that now. See how that goes. Wrong answer. Nice. Oh, it's supposed to be sorted over here. Yeah, this whole part is supposed to be sorted. And we'll say the new right portion looks like this. Looks like this. It's sorted. Let me just say plus the right side. See what that looks like. Oh, okay. Alright, that means it's time to go to bed. Time to stop. So that's a little bit better. And Python. Still kind of involved, but a little bit better. It's just kind of a lot of like string manipulation going on here, but not too bad overall, I would say. So let's see if we can code this up in Clojure. It's definitely going to be more complicated in Clojure, but this whole bit is just this giant let under here that we've got, this whole portion. We can take a look at that later. And this is just like super simple list comprehension now. Actually, we don't even need to use a function anymore for this. You can just plop it right in there. And wherever you see S, put in W. Amazing. 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 Yeah, so obviously these list comprehensions have equivalences in Clojure. That's just great, man. Let me see if we can do this in Clojure. This part here is which. So this target index, I don't need to do this anymore. I can just scrap this. Let's see if we can do this though. Which, and it's going to be bound to this function, which would be, alright, we're going to do a max over a list comprehension, which we can make one of these a -1. I think, right? Clojure max. Yeah, cool. And it needs to requires at least one argument anyway. So we've got that. Now the idea is it's going to be filter. We're going to use a filter, and we're going to use a map. No. What we want is indices. So it's going to be the range. It's going to be the range of the count of W, right? Range of the count of W, and we're going to filter using this anonymous function with 2 arguments, and it's going to be yes. It's might even be just a simple. Actually, this might just be better with a reduction. The thing is, the filter is not going to be that easy to apply here because we want these pairs to loop over. So actually, there is such a thing as pairwise, which would be interesting here. But that's not what we're after. We want to reduce, maybe even transduce. We want to make a reduction here, and it's going to be on, let's do a decrement of this guy. Can we get this right? We could try. A reduce on starting with -1. We'll put the maximum in there as well. We're going to have 1 input, and we say, yeah, okay, never mind. No, we're fine. We're fine. We don't need to do it this way. We can do this will work. So we filter on this using this lambda expression, and all it's going to be is if this input parameter, if we take W, if we get this index for W, and then we get this index +1 from W, and then we compare the two, and we convert them to integers. So can we do Clojure character to ASCII order? Yeah, this one. Alright, so you just use int. Okay. So we use int here. Is there a way to apply int to both of these? Okay, I guess not. Okay, and finally we want to say the value to the left is smaller than the value to the right. Is that what it is? What did I say? Yes. The value to the left is smaller. We're going to filter on all of that and then get the maximum. And that's going to be what we bind which to. Heck yeah. And then, so we don't need any of this other stuff. This character index shenanigans, all this stuff. It's not necessary. Which character index? I'll just say which. Okay. And then, so that's our list comprehension. Which, no answer. Otherwise, now the rest of this we could technically leave the same, I think. I think most of the expense was probably right here. I don't know, do I want to put this over, put all this over under the let? Not really. I kind of want to leave this where it is. I've got this let and this if. Let's see if this works. Let's see what we do now. I never knew what you needed. I just know I'm wrong. I know it's hard for you to believe I'm gonna die. I don't know. I should know the words. Which character index? This has got to be replaced. Oh, no. Hallelujah, 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 hallelujah. Class cast exception. Copy cast to number unnamed module bootstrap. Where is that? Which line? 259, 37. Looking for main CLJ. CLJ 107. You know, this might just be something else entirely. Okay, let's try that again. Sometimes you just have these errors that don't make no sense. That don't make no sense. Alright, how do we do here? How are we doing? How are we doing? Okay. Okay, alright. Oh boy. Class cast exception cannot be cast to class number lazy sequences in unnamed module of loader app module base of loaders bootstrap. What is going on? This grader invokes static core 10 vigorous grader invoke 6. I don't know what's going on here. Excuse me. But it's not quite looking right. Which line though? It's having a hard time compiling. Hallelujah. 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 I don't know what I did to cause this to not compile. I don't know. I don't know. I don't know how I feel about programming Clojure, you know? I feel like it's way too hard to figure out what's related to the compiler errors. Like, I'm okay with not having like super, you know, like super, well, oh wait, oh, max seems to be the issue. Oh wait, never mind. So it's probably here is the problem. Ah, of course. Got it. Yeah, that makes sense. I know let's see what's wrong. See the problem? Yeah, okay, that's a lot faster. Nice. So, yeah, those of you who are paying attention, some of you probably realized what was wrong. Max taking as input a parameter and then a sequence is actually not, it's not the correct way to invoke a function like this one, because it's going to take two parameters, then a number and a sequence, rather than a number and a bunch of other numbers. You could actually use apply, which will then actually turn this into a bunch of numbers rather than a sequence of numbers, which is a little confusing, but it's makes sense if you think about it. You have yeah, this takes a bunch of numbers as arguments. Like it's a variadic. It's not a number in a sequence, and so you convert this sequence to sort of a variadic input. Cool, very cool. All right, and it works. I think this should be enough for our problem. Should be enough to move on. If we go to hallelujah, 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 hallelujah. Oh, we're still timing out. You can't be kidding me. No. Is this a joke? Is this a joke? Ah. Wow. That's amazing. That's wild, dude. Oh my goodness. That's too funny. We're gonna rename input too. Just override it. Boom. Done. Jeez, man. Come on. Ah, it's hysterical. Oh my goodness. This is nuts, dude. This is nuts. There's 100,000 of these. Hold on. We gotta make it stop. Oh my goodness. That's too funny. Just comment that out. Oh boy. It's going, I think. Give it some time. So this is a lot longer than 8 seconds, huh? Yeah, there was no way I was going to be able to do this without using this list comprehension up here. Absolutely not. This is was not going to be possible. You gotta be kidding me though. Like this is, dude, that's so much time. It's crazy. Python is so much faster. It just doesn't make any sense because Clojure compiles to Java, which is like, why is this taking so much time? This is ridiculous. This is ridiculous. Could also use reduce for this as well. Would do the same thing. So anyway, right. Hallelujah, 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 hallelujah. Alright, I'm gonna go get the Python code and try to copy that. Dude, I'm so sad now. I'm sad. I'm sad. Python code here. You get a lot more time for Python, but this is like way over 10 seconds it's taken. It's taking literally forever. Did I use, or did I use Python 2? Did I lose my Python code? Did I make a mistake? Did I? Uh-oh. That's not good. I didn't mean to do that. No. I reset. You're kidding. Alright, let's go to my submissions. There we go. Okay. So it's still going. That's been going for a while, huh? Dude. It's amazing. Did this in 10 seconds? 100,000? Yeah, I guess so, huh? Sheesh. Why isn't Clojure faster? Why is my Clojure so slow? Jeez, man. Alright, which, so let's do that. Make right be a string. So bind right to w which plus 1. Alright, let's do that. Let's get rid of all this. Okay. And we'll just put this on one line here. So, okay, so right is going to be w which is, what does that mean? It's going to be to the end of substring. Of which, and there's start and end, right? So we'll do which plus 1 to the end. I think substring in Clojure looks kind of weird too. It's got like, I need to go to sleep. Yes. Oh no, start, end. No, that's fine. That's fine. Okay. So good. That's the right side. Then we have right minimum character, list comprehension, the minimum list comprehension. So we do right min character, which is just apply min to, this is filter ord x greater than ord which, right? Similar thing, almost exactly the same thing here as here. We can do this too and make things a little better. It's going to be the integer value of this is going to be wait a minute, right min character is going to be the minimum of things that are greater. So this value is going to be greater than this w of which. Alright, this character, you get this character converted to an integer. This thing's got to be greater. Oh, these are only the ones that are greater, but it's the smallest one that's greater. And then the range is it actually doesn't even need to be get w, it could just be this thing. Could just iterate over. Actually, no, I think you do need to do this because of not counter w anymore. It's going to be this right side. I think you got to do it this way because of the strings work. Now I don't know if this get on strings is kosher. I don't know if this, maybe the slowdown is coming from this get. If get is linear on strings. Nth is what we want. Not sure if there's like efficiency issues with using these values. Hopefully it's efficient enough. Right, to randomly access the strings this way, because that would be pretty awkward if we couldn't. Let's get this right min character, and then you want to get this index. Right, dot find index of. S value, index of value, and S optionally searching from index. String or character in S. Okay, I see S value from index. Okay. So index of right is the string, and we want value is right min character, and we don't really care where we start from. Now finally, you've got this okay, now there's this mess, which I'm getting tired of hopping back and forth. Now we're gonna join, so we've got, first we gotta sort this. Now this is really interesting. This is like, you're gonna build this right hand string again, this right index Also, that's not in the right spot. Alright, I guess these need to be moved over. This is like, oh boy. So this is all just substrings, right? So this is like, right is going to be redefined as the, these are all substrings, which, oh, can we just conjoin everything? We're going to conj everything, then we're going to sort it, and then we're going to join it with, just like that, and we're going to apply conj to all of these things, which are, I don't think this should even be a vector, or this should be, this doesn't even make sense. Whatever, I guess it's fine. Oh boy. Uh-oh. Holy smokes. Alright. Just, okay. Nah, you know what? Forget it. We don't need all this. Well, how do you sort a string though? Can you sort a string? Maybe you can. I hope you can. If you can't, it'll be sad. Alright, this is gonna be the right side substringed up to the right index. Start to the end. So it's actually 0 to right index. And is it inclusive? I don't think so. Let's find out. I don't think so. On the right side exclusive? Yeah, the right side is exclusive. So doesn't include that character. Then does include nth which W. And then we have the substring of right index. Start point is right index plus 1 incremented. And that goes all the way to the end. And this is sorted. And that's what we set right to. We join this whole thing. Yep, and we return W up to which is actually just okay. Start 0 which concatenate everything here. I don't think we need to apply, right? That's fine, that works. These aren't, I don't know, this is fine. Is this a character becomes a string? I don't know. I don't know what happens here. Okay. Yeah. Oh, no, this is, yeah, okay. Alright. Okay. And it's still running. It's still going. That's fine, we can stop that. It's supposed to take 8 seconds, that was like 5-10 minutes. Still was going. Holy guacamole, man. Wait a a second here. Delete this. Try again. Alright, it's time for bed, but I just want to see how long this takes. If it doesn't crash. It will resolve symbol which plus 1 in this context. Amazing. I don't think it's correct though. Let me run this on some smaller test cases. There's kind of no reason, well, there's no reason to be doing this. It's like, this gives me more familiarity with the language, which has its you know, sort of positives. Yeah, okay. Alright. Hallelujah. 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 Yeah, just an exception. Okay, that's kind of what I expect. Index of. Really? Also could probably close these things. Hallelujah. Yeah, dot string we need. Okay. Index of Clojure dot string. I think / we need. The reason why I kind of want to throw it in the whatever that thing is called. What do you call this? The online compiler is because I want to use a smaller test case without like messing around with test cases. Cannot cast to Java lang string. Really? Where is that happening? Index of long cannot be cast to long. Really, it's the index of that's causing an issue? Right min character. Oh, because this has got to be a, gotcha. Yeah, I understand. I understand. Hallelujah. Hallelujah. Early to sleep. No pointer exception, sweet. Where does that happen? Is this runtime? No, it's, oh yeah, it's runtime. Where is this happening? Int cast. Apply to var, apply to devoke, invoke static. Invoke. Load file, load. Oh, I need to sleep. I need to go. These, I really don't like messing around with the compiler errors you get from Clojure. I think the Clojure compiler errors are just terrible. They're just not really very good. Yeah, I don't know how I feel about Clojure. I don't know, man. Conflicted about it. There's a no exception in here. Where did that happen? What? Invoke static. idiomatic solution CLJ 221. Which line is this on, though? You know? Which line is this? Say 31 anywhere here. Hopefully. There it is. 2. 16. Oh. That kind of makes sense. Gives you no pointer exception. One of these is null? Oh. Substring the start. Let's write index. Hallelujah. 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 Oh, 1 second. Yeah. Okay. All right. Move this to the side here. So what are we doing here? Oh boy. Oh, there we go, substring. Ah, that's what's wrong. Okay, so something's wrong with this substring. So I wonder what that means, though. It does say which line it is, does it? Yeah, it does, 16. Okay, never mind. I take it back what I said about these compiler errors. So one of these substrings is causing an issue. Alright, the question is why. So this is supposed to be the left side, and this is supposed to be the right side. And this is supposed to be the replacement character, and it's supposed to have left, right, and then replacement in the middle. And then concatenate all three, and then sort it. But the problem is it's a null pointer exception. Integer cast. Is this not an integer? index of? Oh, that could be the problem. How is the value not found though? This is... I think I see the issue. Okay, let's see if we get this right min character here. I'm curious. Zero. Okay. Oh, this is an index, that's why. I forgot. Oh, I completely forgot about this. That's why this is causing problems. Right, that makes sense. Yeah, the list comprehensions in Python are just like a lot easier to use, I guess. Okay, no, it's not this that we want. We want actually composition of functions then. So what we want to do then is, yeah, a couple of things. Actually, yeah, okay. Then this is just the string we want to go over. And then these are not, oh, I didn't even catch that. Did not catch that. I feel kind of silly now, having not caught it. Okay, let's try again. These are like pretty, so kind of like trivial issues, problems, mistakes. Alright, what do we get? Debug, BGK. Okay, good. So we found that this, okay, so that actually worked. Alright, cool. But now we have another error. Apply. Okay. This one. Thought maybe this would be a problem. You know what we can do? We can just make this even simpler. Now I wonder what happens if we do this. So these are all ints that we return. Huh. Oh wow. Okay. Interesting. And finally call it make it a character. Again, convert it back to a character. Alright. Interesting. And then, and I guess it's gotta be joined after all. Oh, just keep going here. Clojure string join. Let's try again. Oh, it works. Okay. But it takes a while. It takes a lot of time. That's going to take a lot of time. I can almost guarantee it. Yeah, it's way over 8 seconds. Let's see. 100,000 times, I don't know, 5 milliseconds each. 5 by 1,000. It's 500 seconds. 8.5 minutes. So what can we do for 8.5 minutes? Oh my goodness, man. Why does it take so much time? This is crazy. This is not efficient at all. This is ridiculously slow. Now granted, it might be because I'm creating ridiculous numbers of substrings here, which I'm gonna just go ahead and assume that every time we call a substring, it just generates another one. But oh my goodness, man. Just a whole lot of hooey going on here. Oh man. Yeah, this is running slow. Alright, so that's not gonna pass. Even with this huge optimization in here, still really slow. Dude, this is depressing. This is like, it's brutal. Alright. We can build the left and the right vectors and manipulate those, and then join them at the end here. It's just kind of expensive, I guess. Can try that again. Last time I did that, which was like create a vector of the substring. Yeah, that's what I did before. So I had before. Let's create a vector of the substring, which was W, and which. And then also create a vector on the right side, which was substring W. So the left side would be from 0 to which inclusive, or exclusive would include which. And then this would be W from including which to the end. Right, create these two vectors. And this right min character would be map these to integers. Well, it doesn't really have to map to integers. It could be this collection, this vector of characters now, and then you would say which character is right. And this is an integer, so convert that to an integer. When you compare it, it's not an integer, that's a character, and then of the characters, you want to get the smallest. I think you can compare characters to each other. Now that's the tricky part. After you've filtered, then maybe you want to map character or map int, and then map back to character. Yeah, that's really awkward, I think, in my opinion. Too bad you can't compare characters to characters. Maybe you could do this though. Yeah, no, I think you gotta do this. I think you're stuck with it. Yeah, it doesn't really help much, does it? No. It's so slow. That's ridiculously slow. Index of. Okay. Vector. I don't know if this even works. Maybe, hopefully. There's all these functions we call here. So left, we're going to say set which of left to, we could say val1, val2. Val1 is going to be get. It's going to be which character, actually. Yeah. Get left to which. Val2 is going to be get right of right index. And then left is going to be set left. Val1 or Val2. And right is set right. Val1. And this is going to be which. And this is going to be right index. Right. And don't need all this anymore. Can just join, apply join. Left and right. What do we get here? Does it compile? That's the question. I need to sleep. I need to sleep. Well, let's see. How do we do here? How do we do here? Wrong answer. Time exception delimiter. slash delimiter. List reader. And try again. Try again. Where? Are you kidding? Is this a joke? I joke to you? Am I a joke to you? Okay. Doesn't work. Nice. Parse sequence analyze. What do these do? What? Join. Oh, got it. Gotcha. One more time. Holy smokes. Core set compiling. Arity exception. Where is this happening? What? The second line? Oh my goodness. Wrong number of args passed to core set. 19. Oh, that's why. Let's go for vector. And pop, I think it's association, so we need to do. Keep up. Associate, not set. Set is actually a set. That's my mistake. That's my mistake. Oh, come on. Index out of bounds. Which one? What do you mean? What do you mean? 32. Evaluate invoke. Number 2. Invoke static 20. Maybe that's the one. 20. Huh. Right. Okay, let's try again. Let's try again. Ah, man, I'm really gonna go to sleep. Two. That's really funny. How did that happen? What do you mean? What do you mean? What? Are you kidding me? Is this a joke? Am I a joke to you? How did we get 2 for this? And then this is just B. How does that even happen? How does that even happen? Oh my goodness. Shouldn't this be the problem then? That instance? What is even going on here? What is even going on? Hello? Hello? Oh. How's that? What? Doesn't make any sense. Doesn't make any sense. Holy guacamole, man. Oh my goodness. Oh my goodness. My goodness gracious. My goodness gracious me. And then okay. Try again. Alright. So we have B, index of B. 2. What? It's a string, that's why. I could write a routine for this, but there's gotta be something built in that's better. Dot index of. Really? What the string one? Examine. Nice. How come that one doesn't show up? The dot index of. Oh, because this is a Java. Oh, interesting. Interesting. Very interesting. Okay, let's go. Let's see how this goes. Dude, I don't know. It didn't throw an exception. The BB0. Thank you. All right. Didn't know what to do with this function call. This string function call. Now what's the problem? So string join left right. I think it's we apply it, right? Probably need to do something like this. I don't know. I don't know what to do. Try to get something that works. I thought this was gonna be easier, but it's not. It's not. Don't know how to create sequence from character. Which join, apply, join, 180, join, 180. Apply, invoke static 21. So somewhere in here is 21. Yeah, so this now has an issue. This one. Okay. Okay. I don't know why I've got all this like angst going on here. What do they call that? Like sign, you know? Because this was my choice after all. This was my choice to do this. I don't know. I'm like, for some reason, I want to do it faster than So BA, so you know what we can do? We can actually conj these two. I think we can start with that. How about that? Why don't we do that? I have an idea. String apply conj left with conj with right. And maybe we should apply conj as well. Let's see how this goes. Yeah, it worked. It was incorrect, but it worked. Apply, apply, apply. Output. Okay, we can get rid of the output here. Oh yeah, so these are just like vectors of characters, so that's good. And I'm wondering, what do we get for... What do we get for this guy here? Do we get what we expect? We do. Hey, that's pretty good. Almost. There's one piece missing. This should be sorted. I forgot about that. Alright. And conjugate these. And then the only issue is, should we apply string and string apply? And that's it. And that ought to do it. That ought to do it. And I think what the issue is here, when we run this, it runs so slowly because we're doing so many mappings and recreations. Basically, each time we have a new string, we recreate it over and over and over again. Like we rebuild this string like 10 times throughout this program, and it's terrible. And there's no way that this will work properly. Not that it won't work properly, but it won't work quickly. This is just extremely slow. Alright, I think what we're going to go ahead and do is give up on this one for the time being. I mean, we solved it with Python. That was pretty good. That was pretty quick. But this is like, I don't know, man. I don't know how to... I don't even know how to optimize this. This is like crazy. Kind of wish I could see other people's Clojure solutions. Not sure if I want to use Clojure for my programs. Not sure if I want to use functional programming at all now that I'm getting a little more familiar with it. I kind of need to work with more problems in order to get more familiar. But, dude, I'm disappointed. I'm sad now. I'm sad. Well, yeah, we can let this run. No. We want this. No, we don't want this anymore. I'll take that back. Alright. I'm gonna let this run. Let me end stream. I'll talk to you soon. Thanks for coming by, checking out the video, and yeah, dude. Oh, it sucks. It sucks. We need it's depressing. We need what do we need? Oh my goodness. What's the problem here? I need to figure out like a way to not copy this a million times. So we have 1 copy, 2 copies, 3 copies, 4 copies, 5, 6, 7 copies, 8, 8 copies. These are 8 linear time complexity executions. That's 8. And then this is 9, 10, 11. So yeah, basically every single execution has 11, a factor of 11 multiplied through on it. But somehow the Python version is fine. You know, like the Python code looks like it should be pretty slow too. I don't know why. For some reason, and there's also here too. There's more. There's more than just 11. There's 12, 13, 14 times. I don't know. I guess the Python code has some some optimization underneath or something. Who knows? But this takes a really long time. Let me also. All right. Let me go. Like I don't want to go. I don't want to accept it that this is so slow. But this is really slow. I don't understand why. So yeah, thank you for watching. Take care. Talk to you soon.